This and future lessons will teach the basics of flight at a more in-depth level, from this intro flight until what a person would undergo taking flight lessons in real life. As a former flight instructor, I will take you on a journey of what getting a private pilot license would be like. This is a Cessna 152. They were built from 1977 and 1985. It's powered by a 4-cylinder Lycoming O235 engine, producing 110 horsepower. The Cessna 152 has an empty weight of 1,081 pounds and a maximum weight of 1,670 pounds. The 152 can hold 26 gallons of fuel, has a range of approximately 320 nautical miles at 75% power at 8,000 feet. Service ceiling is 14,700 feet. Typical cruising speed is around 100 knots depending on power setting. We're first going to go around the outside of the airplane. I'm going to teach you the components of the airplane. Here we have the propeller, the spinner, and the landing light. The 152 also has a tricycle configuration fixed landing gear with hydraulic brakes on the left and right main gear. There is a strut on each side of the airplane to help support the wing. The front of the wing is known as the leading edge. Here we are at the right wingtip. We have a green navigation light, static wicks, and an aileron. We also have the cowling, fuselage, empennage, or tail. This is the vertical stabilizer and rudder. Below that is the horizontal stabilizer. On the top of the tail, the V-shaped wire is actually a VOR antenna. Believe it or not, the left side of the airplane is just like the right side of the airplane, so we'll skip that part. The fuel system has 2 interconnected wing tanks. Each wing root has a fresh air inlet. The air flows in from the inlet and comes out here. There's one on each side and can be opened and closed by either occupant. And this metal piece doesn't do anything other than keeps the door from opening too far. I think that pilot looks like Michael Jackson. On this section we have the static port, pitot tube, and stall warning system. The static port and pitot tube work together and independently to power some of the instruments. The stall warning system operates on air pressure. As the angle of attack increases, low air pressure enters that small hole and triggers the stall warning horn. We're now underneath the nose of the airplane looking towards the left wingtip. Here you have the linkage for nose wheel steering. This is a shimmy dampener. The shimmy dampener keeps the nose wheel from turning left and right. Think of it as a shock absorber for the nose wheel. When dampeners go bad, the nose wheel will shimmy back and forth so fast that the wheel will vibrate. And here we have the engine air intake and the exhaust. Now we're inside the cockpit. We're going to go over each of the basic instruments, explain what they do and how they work. First we have the airspeed indicator. The speeds on the outside of the ring are knots indicated airspeed. The inner arc and the arrow are in miles per hour. The airspeed indicator uses the static port and the pitot tube. The static port senses ambient air pressure. The greater the difference between the pitot tube and the static pressure, the higher the indicated airspeed. The attitude indicator gives us an artificial horizon. It should be pretty close to the real horizon outside. The top part is blue, representing the sky. The bottom part is brown, representing the ground. Each line on top represents 10, 20, 30, and 60 degrees of bank. The brown shaded area on the bottom has 2 angled lines representing 15 and 45 degrees of bank. The attitude indicator can also be adjusted with this knob. The attitude indicator also gives pitch information. The first line is 5, then 10, 15, and 20. On the bottom, it shows 10 and 20 degrees of pitch. Next we have a clock. Everybody knows what that is. To set it, move this knob here. To the right of the clock, we have the altimeter. That tells us our height above sea level. For it to be accurate, we have to set the local altimeter setting with this knob and set it in this window. If you do not know the altimeter setting, but you know the field elevation, you can set field elevation in the altimeter. Once you've done that, the barometric pressure in the window will be very close to the barometric pressure outside. These are sometimes called VOR indicators. Their actual name is course deviation and ILS glide slope indicators. And that's probably why nobody calls them by their actual name, because that's a mouthful. We'll get into those more on another video. And on the bottom left, we have a turn coordinator. This is electrically operated. This is used more in instrument flying. If we take the wingtip of the little white airplane and put it on the left or right indexer, you'll see below the ball it says 2 minutes. When the wingtip is on that indexer and you turn, it'll take you 2 minutes to make a 360-degree turn. That turn rate will be exactly 3 degrees per second. Next is the directional gyro. It looks like a compass, but there are no magnets inside like a compass would have. It uses a gyroscope. It's set in reference to the magnetic compass, or if you're aligned with the center line of the runway before takeoff, you can align it with the runway heading. Both of these instruments are powered from an engine-driven vacuum pump. They need a proper amount of suction to operate correctly, and the manufacturers were nice and put a little suction gauge right here. If it's outside the green arc, these two gauges may be inaccurate. The vertical speed indicator tells us our vertical speed in hundreds of feet per minute. For example, 100, 200, 500, 1,000, 2,000. The primer atomizes fuel going into the carburetor. It's used on cold days. It's used prior to starting the engine and helps the engine start easier. The master switch controls the electrical system. There are two sides, alternator and battery. With the battery off, you get these indications. As you can see, these gauges need electricity to run. If there's no power, they go to 0. When the right side of the switch, the battery side, is turned on, the battery supplies power to the electrical system. The left side is the alternator that only supplies power when the engine is running. The alternator charges the battery. And this has no effect on engine operation if both switches are turned off. The engine gets its electrical power from magnetos to power the spark plugs. As you can see, the ignition system has off, right, left, both, and start. The off position takes power away from magnetos, and that will shut down the engine. That is not the preferred shutdown method. When the right position is selected, power to the left magneto is disabled. When the left position is selected, power to the right magneto is disabled. The normal position for the ignition is both. Each cylinder has 2 spark plugs. One set of spark plugs is run by the right magneto. The other set of spark plugs is run by the left magneto. If one magneto goes bad, or the left or right side is selected, only half the spark plugs will be working, and you won't get the proper fuel combustion, and you will develop less power. Above the ignition, we have fuel gauges. The fuel gauges read in pounds on top, gallons on bottom. The fuel tanks in the Cessna 152 are interconnected, so the fuel gauges should always read equal to one another. We also have an oil temperature and oil pressure gauge. When it's very cold outside, it's common to have low oil temperature and high oil pressure. As the oil heats up, the oil pressure should decrease. And if we're ever flying and the oil temperature goes high, ways we can combat that is to increase airspeed, reduce power, or increase mixture. All those will help lower the oil temperature. And you'll see here in a second we'll add power. The engine temperature will increase, thus increasing the oil temperature. And you'll see the oil pressure move. While the engine's run up, I'll reinforce what I said about the magnetos. I just switched to the left magneto and the RPMs dropped. Back to both, RPMs increase. To right RPMs drop again, back to both, they increase back to where they were. The drop in RPM, or the mag drop, is normally 100 to 150 RPM. It's not a lot, but it is noticeable. Next is the carburetor heat. When we pull the carburetor heat out, that puts heat into the carburetor and the RPMs drop. This happens because the amount of fuel going into the carburetor is the same, but the air density is less because the air is hotter. That makes the fuel mixture too rich. Next we'll discuss this lower switch panel. We just press the dome light, that turns the red light on above our heads. Next is the pitot heat. That heats the pitot tube. That would be used in the event the pitot tube iced up. Or we could use it as a preventative if we were flying in weather conducive to icing. Next is the nav light switch. Navigation lights are used at nighttime to help other airplanes see what direction we're going. You have a red light on the left wingtip, white light on the tail, and a green light on the right wingtip. We next have the strobe lights. Strobe lights are used in the daytime and the nighttime to help other airplanes see us. Next is the beacon. The beacon's another anti-collision light that should be used at nighttime and in daytime before engine starting to alert ground personnel you're ready to start. The last two rocker switches are the taxi light and landing light switches. That simply turns on the light at the front of the airplane so you can see to taxi and see to land. Next is the elevator trim. Rotate it up for nose down, rotate it down towards the floor for nose up. When the trim wheel inside the cockpit is moved, this tab moves. This tab is only on the right side. You can see that here. The right side has hinges, the left side does not. Here's what happens when you move toward nose up trim and nose down trim. While flying with air load on the tail, when you go nose down, it pushes the rest of the elevator down, even though the trim tab is moving up. Cabin air opens a small flap on the side of the fuselage, lets in cold air. Cabin heat comes from a shroud around the muffler. When these knobs are pulled on, the air comes out by the pilot and passenger's feet. And up here is the ADF radio, and that will come in a later video and get a whole video to itself. And up here we have the ammeter. This shows the amount of current coming from the alternator to the battery, or from the battery to the airplane in the event that the alternator is not working. What that really means, if the needle's to the left, the battery is discharging. Eventually your battery is going to die, the alternator is not working. If that happens, this light will come on. If the ammeter shows an excessive rate of charge, you would want to turn the alternator off and consult the emergency checklist. Last but not least, flight controls. When you turn the yoke, it points towards the up aileron. The other aileron goes down. And we'll view the same thing again, but from the outside. You can see the yoke turn to the right, and the right aileron goes up, the left aileron goes down. When we push on the rudder pedals, this happens. That's left, that's right. However, this airplane does not have rudder trim. This is what it looks like when you pull the yoke all the way back and all the way forward. The 152 has electrically operated flaps. Besides 0, there are 3 flap positions: 10, 20, and 30 degrees. 0 to 10 degrees of flaps are used for takeoff. 30 degrees of flaps are normally used for landing. That's it for this video. Join me next time. We'll do climbs, turns, descents, and we'll do some experiments with the trim. And remember, please click the subscribe button.